Hello everyone, welcome again to another explanation of the singular numerical relativity, and this time I will explain what the singular numerical relativity is going to do, what it will make us understand. And you will notice that in the course of explaining everything, it will be focusing on the holographic principle. Therefore, this topic here is about explaining holographic principle as the mean by which we will be able to explain the whole theory. So now let's say that the singular numerical relativity will, in its majority, explain holographic principle. However, we have to know that this theory comes as a package of solutions, a package of answers to all the fundamental questions that we have been asking ourselves in cosmology and physics. So it is going to explain all of that by simply explaining the holographic principle. However, you have to know that the holographic principle is not the main subject, because we cannot explain the holographic principle without explaining relativity, which is based on numbers. So what it is going to explain in addition to this holographic principle, it will explain quantum gravity. And speaking of quantum gravity, we will be matching the geometry of space-time with information. Then we will also explain the singularity. This one I already talked about the singularity in the very beginning in my introduction, so I will not so much elaborate because we still have it explained at the end of this topic. Then we will explain about determinism, uncertainty, measurement, and probability. These are very controversial issues in quantum physics. The entanglement of bits of information. Here we will see how bits of information in the universe are interconnected. And also we will talk about the accelerating universe. We know that the universe is expanding faster and faster. And these scientists are wondering, why is it so? Then we will be explaining also about the arrow of time and the increasing entropy. Entropy will be increasing and increasing because of the properties of numbers. And also we will be touching the Big Bang. The Big Bang here, we are going just to talk about the energy in the beginning. That energy that we will call the universal prime energy. How the singular numerical relativity is going to solve all these issues. First, I would like to tell you that the singular numerical relativity has two parts. In the first part, it will make predictions. And that's what we started seeing when I was introducing the structure of numbers. we see there that it makes predictions, and these predictions are based on the physics that are related to numbers. And what are those physics? Numbers are subject to acceleration, deceleration, expansion, projection, and explosion. So a number can be accelerated, a number can be decelerated, a number can be expanded, and a number can be projected or exploded. These are the physics that we are going to study, and all come with formulas that I have not mentioned yet here. So, in order for us to confirm all of this, in part 2, we will be seeing how to implement all these operations. And these operations are going to help us to really explain the holographic principle. We know that the holographic principle is based on this simple explanation of information being preserved on the surface of the black hole. And here, we cannot do it. We cannot explain the holographic principle without producing first an object. So these operations that I have mentioned previously, which are acceleration, deceleration, projection, expansion, and explosion, will help us to construct a geometrical object that we will later throw inside the black hole, and we will see how this thing will be dismantled, and all the information from the object will be mapped on the surface of the black hole. So this is what we are going to explain here. We will first construct the object, and in the process of constructing the object, we will be collecting information from that object. Because as the constructors, if you are the mason of the constructing a house, building a house, then you know how many bricks you put in that room, how many windows you put in the house, what are the colors you use for paint, and all of that you know in details. Therefore, we have to do the same here for the object.